Okay, I wanted to review with you the groupings along the periodic table. And just as we get started, remember a group does go this way, it's a column. But periods go horizontally. So this is group 1 all the way down here. This is group 2. But the periods are numbered horizontally. So this is period 1 and it's going in this direction. This is period 2, period 3, period 4, and then 5, 6, and 7. So remember, the periods are horizontal rows going this way, but groups are numbered 1, 2, all the way through 18 this way. And these groupings are kept separately because they're special series. So let's start with the naming again. And I know we talked about this, but it's a good review. Our first group are very active metals. We call those the alkali metals. Now remember, the periodic table is grouped according to similar traits. And a lot of times we call these families. So group 1 is called a family of elements because they all are very similar to each other, just like families are. So this is group 1, the alkali metals. Group 2 are the alkaline earth metals. Again, they're all very similar. Elements like beryllium and calcium and barium, they all have a lot of similar traits. And that's why we group them together. The next group starts here. It goes all the way to here. It's called the transition metals. When we study atomic structure, you'll know why we do call them the transition metals. Okay, and then this group here, these next several are named after the top element. The top element here is boron. So this one's called the boron group. The next one's called the carbon group. Because again, carbon is the element that's there. And followed by the nitrogen group. And this group is the oxygen group. So again, boron is here, carbon is here, nitrogen here, and oxygen is here. So that's why we are naming those groups that way. The next are called halogens. That means salt forming. And when we cover chemical bonding, you'll see why we call those halogens. These are very commonly found in various salts. And lastly, the noble gases. They're called that because they really don't react at all. So they're very noble. They don't need anybody, so that's why we call them that. Now there's some elements here that all have M's on them. Okay, they're called metalloids. Now they're called that because they have traits like a metal, but they also have traits like a nonmetal. And you're going to find that this jagged line separates the nonmetals from the metals. So this whole side of the periodic table, all the way up to this line, that's where metals are. So I'll just label it this way. And after this, they are nonmetals. So you see how the periodic table is really organized according to similar things. You know, all the metals on one side, and it does include these guys down here, and the nonmetals on this side. But there are some that have traits of both metals and nonmetals. And when we cover chemical bonding, we'll talk more about those, what those traits actually are. Now last to talk about are the intertransition metals. Again, all these are metals. And again, when we cover atomic structure, you'll see why they're called intertransition metals. But there are two series, the lanthanide series and the actinide series. And why are they called that? Well, lanthanide series starts here, really, but we start from here and go all the way to this side here. They're pulled out separately because it saves space when we're looking at them. And then the actinide series, I guess, essentially starts here, but we'll call it down here. The actinide series is all the way here. Again, these special rows of elements are pulled outside so that the table doesn't get too long. It's easier to view. Now, when we cover nuclear chemistry, we'll be talking more about what some of their special traits are in those two series. So there you go. That's our organization of the periodic table. Now, the next thing to talk about, there are charges that each group has on them. And I want you to add this to your periodic table now. The group 1 here, they all typically have a +1 charge. So write +1 on the top there as well. The next group has a +2 charge. And what that means is these elements generally tend to lose electrons and become positive in charge. Again, a topic we will cover with chemical bonding. The The transition metals, they all have variable charges, so we're not going to label any charge on top of that. And same thing with the inner transitions. Those elements can have lots of different charges, so we don't typically identify them. The boron group, a lot of them have a +3 charge, so we can write that on top of there. And the carbon group has a plus or -4. That means some of them make +4, some make -4. But there's still quite a few charges possible in that row. But typically plus or -4 works well for that. And the next group over, the nitrogen group, a -3. A lot of the elements in that group do make a -3 charge. But again, there are some exceptions. And the next group, -2. That's pretty typical of this group, so you can label that -2. And then this one here is -1, all the way down, and lastly 0. Again, our noble gases, they really don't make a charge on them. So if we were to just practice a little bit on this, let's say I want to look at magnesium. Well, magnesium, I'm just going to write its symbol as Mg. So we typically, don't write the whole word out for it. We just use the symbol for the element. So that's in group 2. So I'm going to say magnesium is +2. Let's go here and pick bromine. Again, bromine, I'm going to label that just as Br. I'm not going to write out the whole word. So I'll just say Br. And it's in this group here, and we label that to be the -1 group. Okay, now let's pick one in the middle here. So let's say we have manganese, and that's this one right here, Mn. So I'm going to go Mn. Now here, we can have a variety of charges. This guy can be +4, could be +7, +2. So how would we ever know which one we're talking about? Well, typically we write it like this, Mn, and then we do a parenthesis and write a Roman numeral 4, so that we know that we mean +4 when we say that element. So if elements have more than one possible charge, typically we'll use a Roman numeral to tell everyone which one are we really talking about now. Okay, and that's really the organization of the periodic table.